Slope, as you know, is rise over run. And a little space up here, let me remind you the different types of slope. If it's up and to the right, it's a positive slope. If it's up and to the left, it's a negative slope. If it's straight left to right, it's a zero slope. And if it's straight up and down, it's an undefined slope. So, what I'm being asked to do to start out this problem is I'm being asked to use rise over run to find the slope connecting A and B. So let me get my ruler so I can draw a nice line from A to B, just because. Okay. Now I have to find the slope. Remember, slope is rise over run. The first thing I do is I get 2 points. Well, there they are. The second thing I do is I figure out if it's positive or negative. I'm going to put a little P here because it's definitely positive. Now I do rise over run. I start at 1 point and I figure out how I get from A to B by going up and down blocks and over blocks and not cutting through people's yards. So I go up 1 block, so I rise 1, and I run 1, 2, 3, 4. I rise 1, I run 4. I rise 1 over 4, 1 over 4. Okay? That's how I do rise over run to find the points connecting A and B. Now I have to do B and C. So let me get a different color. Green, which is my favorite color. Where did C go? Where did C go? Where did C go? Where did C go? There it is. There's C. All right. First things first, identify 2 points. Boom, boom. It's negative because it's going up and to the right. I'm sorry, up and to the left, up and to the left, up and to the left. Now I go rise over run. I count up 1, 2, 3, left 1, 2, 3. My rise is 3, my run is 3, and it's negative. Now I can look at this and be like, oh, wait a minute. I can simplify that. You sure can. Negative 3 divided by 3 is negative 1. So my slope is negative 1. Now I have to do A and C. So I'm going to get my ruler. I'm going to draw a line connecting A and C. Step 1 is I identify 2 points. There they are, 2 points right there. Second thing, I determine if it's positive or negative. It's negative. There's my dog in the background barking, probably because someone knocked at my door. Now I do rise over run. So I have to get from A to C. So I'm going to start at A because that way it's less jumbled. I'm going to go down 1, 2. So negative down 2 over 1, 2, 3, 4, 5, 6, 7. Down 2 over 7. Can I simplify that? Nope. So am I done? Yup. Now use the slope formula to find the slope of the lines connecting A and C. Great. So now I have to do the slope formula anyway. Good old slope formula. You are definitely going to see this on the quiz, so make sure you know the slope formula. And if you don't know the slope formula, look it up. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It wants me to use points A and C. So A is left 3 up 2. So A is left 3 up to the point negative 3, positive 2. And C is the point where I go right 1, 2, 3, 4 and don't move. So what I do to do the slope formula is I mark my points, x sub 1, y sub 1, x sub 2, y sub 2, and then I plug them into that formula. So I'm going to rewrite that formula and plug in those numbers. M equals, instead of y sub 2, I'm going to plug in 0. Instead of y sub 2, I'm going to plug in 0. Always put the minus sign in the middle. Instead of y sub 1, plug in 2. Instead of x sub 2, plug in 4. And instead of x sub 1, plug in negative 3. If you see a double negative, which I do, turn it into a positive, which I will. So there's my double negative. I'm going to turn it into a positive. 0 minus 2 is negative 2. 4 plus 3 is 7. Negative 2 divided by 7 is the same as negative 2 over 7. And that makes sense because that's exactly what I got up here. Okay? So that's slope for you. That's slope for you. All right, just adjusting a little bit. Are any of the lines in the graph above parallel? Well, parallel means they have the same slope. Parallel lines have the same slope. Parallel lines have the same slope. Parallel lines have the same slope. This slope is 1 over 4. This slope is negative 1. And this slope is negative 2 over 7. So are any of these parallel? No. Why? Because none have the same slope. We are. You can see it too. I mean, all of those lines cross each other. So it's obvious. But if I were like being asked on a test or a quiz, for example, to explain why, that's my explanation. Okay? Okay. Let me take this paper. Let me give it a good fold. Let me give it a good fold. Look at that picture. Look at it. Look at it. Is the graph on the left proportional? What does proportional mean? Proportional means it's a straight line that goes through 0, 0 and follows a pattern. Look, a straight line. Look, goes through 0, 0. Is it proportional? Yes, because it's a straight line that goes through 0, 0. What is the equation for a proportional relationship? In general, the equation is y equals mx. For this specific graph, though, remember, m stands for slope. M stands for slope, and slope can be rise over run. So what I can do is I can pick that point 0 right there. I can go up 2 to 96. So my rise is 96. My run is 1, 2, which is 6. I know the picture doesn't make it that obvious. It looks like you're going up 2 over 2. But keep in mind, if they label your graph differently, you have to kind of adapt to that. So when I go up 2, I'm actually going up to 96. I'm going from 0 to 96, which is how fast I drive. And I'm going from 0 to 6, which is how fast my father drives. 96 divided by 6 is 16. Speaking of driving. So the equation for this specific graph, over here is y equals, instead of m, I'm going to replace it with 16, and x is x. Remember, when you come up with an equation, y is always y, x is always x, and you're usually trying to find n. Or later, a b, but we're not worrying about that yet. I've heard of keeping a bean, but finding a bean, that's different. That's pretty good. All right. Find the slope in the y-intercept. Oh, okay. It's giving me equations. Slope-intercept form. Let me write it out. This is slope-intercept form. Y equals mx plus b. When y is all by itself, the number in front of x is my slope. When y is all by itself, the number in front of x is my slope. When y is all by itself, the number floating around is my y-intercept. If y is not all by itself, I have to get y all by itself before I can do these guys. Okay, I have to get y all by itself before I can answer these questions. So when it says identify the slope and y-intercept of y equals, this makes me happy because y is already by itself. And when y is already by itself, the number in front of x is my slope. So I can say the slope is -3. And when y is all by itself, the number floating around is my y-intercept. So my y-intercept is +2. So I'll put y-int equals +2. Dunzo. Dunzo, 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 dunzo. Oh, it's so great when y is all by itself. Uh-oh. Looks like y is not all by itself over here. So I have -2x minus 3y equals 12. I have to get y all by itself. The first step that I'm going to do is I'm going to get rid of this whole guy that's floating around by itself. I'm going to add 2x to both sides. Add 2x to both sides. Drop down the -3y equals, I have a +2x and a +12. Do they combine? No, because one has an x and the other one doesn't. So I have to write out +2x, +12, 2x plus 12. Is y all by itself now? No. -3 is in the way. So I have to divide everything by -3, divide everything by -3, divide everything by -3. 2 over -3 is negative. 2 over 3 doesn't simplify. 12 over -3 is -4. Is y all by itself now? So when y is all by itself, the number in front of x is the slope. So when y is all by itself, the number in front of x is the slope. -2 over 3 is my slope. When y is all by itself, the number floating around is my y-intercept, which is -4. Okay. Okay. Mr. Perich, why is this all important? Because my point is to graph lines. Okay? So when I'm given a problem like this, let me zoom up just a teensy bit. I don't know about that. No, let me zoom out a teensy bit. and do that a teensy bit. And that made it worse. How about that? Ooh, catch me outside. How about that? I shouldn't have touched anything. Ugh. 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 The reason why I did all that stuff is because now I have to graph. Remember, slope-intercept form is y equals mx plus b. If y is all by itself, the number in front of x is my slope, and the number all floating around all by itself is the y-intercept. I have an equation, and if it's hard for you to see, let me rewrite it out. Negative 2/3 x minus 1. I can look at that and say y is all by itself. So the number in front of x is my slope, and the number floating around is my y-intercept. Always, 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 always start out by drawing the y-intercept. You go to your y-axis. You put a dot at your y-intercept, which is -1. So -1 is that guy right there. Boop! Now you use your slope to make more dots. My slope is -2/3. Remember, negative slopes go up and to the left or down and to the right. So if it's rise over run, I make more dots by going up 2, left 3, up 2, left 3, up 1, 2, left 1, 2, 3, dot. Up 1, 2, left 1, 2, 3, dot. I ran out of space. So I can go back to my original light blue dot and go down 1, 2, right 1, 2, 3, dot. If you notice that if you accidentally went like down 3 over 2, your line won't be straight anymore. The reason why I put more dots is so that I get the straightest line I can. Down 1, 2, right 1, 2, 3, dot. Take a ruler. There you have it. So again, what I did, for those of you who are like, I think I get it, but I'm not super sure. If y is all by itself, then the number in front of x is the slope. My slope is -2/3. If y is all by itself, then the number floating around is the y-intercept. -1 is the number floating around, so my y-intercept's -1. Always start out by going to your y-axis and putting a dot at your y-intercept, which was -1. So my dot went there. Then I went back to my slope, and I said my slope is going to be -2/3, means up 2, left 3, or down 2, right 3. So I went to that dot, and I went up 2, left 3, put a dot. Up 2, left 3, put a dot. Up 2, ran out of room. Go back to your original dot. Rise over run. Down 2, right 3, put a dot. Down 2, right 3, put a dot. Draw your line. Done. Now, this all works when y is all by itself. So when y is not all by itself, I have to make y all by itself. I'm going to blow that up so you can see it a little bit better. Is y all by itself? No. So I can't graph yet. How do I get y all by itself? Well, -2 is in the way, so I have to add 2 to both sides. So now I have y equals, do these two combine? No, because one has an x and the other one doesn't. Which one should I write out first, the 4x or the 2? How about that 4x? Always put the guy with the x first. Now I can look at this and say my slope is, when y is all by itself, my slope is the number in front of x. Well, my slope here is 4. But I don't want to view it as 4 because I want to view it as rise over run. So I'm going to call it 4/1. My slope is 4, true, but I want to write it out as 4/1 so I can view it as up 4, right 1, up 4, right 1. When y is all by itself, the number floating around is the y-intercept. So my y-intercept is positive 2. You always start out by graphing the y-intercept. So you go to your y-axis, there it is, and put a dot at 2, which is the y-intercept. Now I go to my slope, and I use that slope to make more dots. So 4 over 1 is positive, which means up and to the right. So I go up 1, 2, 3, 4, right 1, put a dot. Up 1, ran out of room. Go back to the original dot. Down 1, 2, 3, 4, left 1, put a dot. Down 1, 2, 3, 4, left 1, put a dot. Down 1, 2, 3, 4, ran out of room. Once you have enough dots, draw a straight line. And there you have it. One more. Now, this is the worst case scenario problem. The worst case scenario problem because y is supposed to be by itself, and it's not even close to being all by itself. So let me rewrite the equation. Negative 2x plus 5y equals negative 5. Is y all by itself? No. I have negative 2x floating around, and I have positive 5 attached to y. Always get rid of the guy that's floating around first, and in this case, I'm going to get rid of negative 2x by adding 2x to both sides. That crosses out. Drop down the 5y, drop down the equals. I have negative 5 and 2x. Do they combine? No, because this has an x and that one doesn't. Which one should I write out first? The 2x, of course. So I'm going to add 2x minus 5. Now, is y all by itself? No. No, I have to get rid of 5 by dividing everything by 5. Everything by 5. Everything by 5. Y equals, can you simplify 2 over 5? Nope, so 2 over 5x. Can I simplify negative 5 over 5? Yup, it's negative 1. Is y all by itself now? Yup, which means the number in front of x is my slope, and it's already as a fraction, so that makes me happy. And the number floating around is my y-intercept. So my y-intercept is negative 1, which means I go to my y-axis and I go down to negative 1 and put a dot there. Boop. I go to my slope and use that slope to make more points. So I go up and to the right because it's positive. Up 1, 2, right 1, 2, 3, 4, 5, put a dot. Up 1, 2, right 1, 2, oh, I ran out of room. So go back to your original dot. Go down 1, 2, left 1, 2, 3, 4, 5, put a dot. Go down 1, 2, left 1, 2, 3. Oh, I ran out of room. I have 3 dots, which is all I need to draw a line. And there's my line. There you have it. In order for you to graph, you have to get y all by itself. Y wasn't all by itself, so I added 2x, and then I divided everything by 5, and that gave me y equals 2/5 x minus 1. Minus 1 is where I start out, so I put a dot at -1. 2/5 is my slope, so I go up 2, right 5, down 2, left 5, and there's my graph.